Hi there, welcome to Effortless Math channel. In this video, what I want to do is introduce you to trigonometric functions, namely the sine function and the cosine function, and I want to show you how we can use our understanding of functions in general and the unit circle to develop a firmer understanding of what the sine and cosine functions look like on a graph. Let's get started. So to begin, it's important to review what a function is. You'll have to remember that functions are like machines. We can take x values and place them inside the function, and depending on what the function is, different things are going to happen to that x value, and that x value is then going to be outputted as a y value. And sometimes we use function notation, f of x. That tells us the value of the function when x is placed inside. So you can imagine if I take a 2 and I place it inside as the input, and let's say my function was x squared, what I'd be doing is I'd be taking 2, raising it to the power of 2, and then outputting a value of 4. That's just a simple analogy for how a function works. Now, trig functions work the same way. We can take numbers, sub them in for x, and get y values out. Now, trig functions are unique because the x values actually represent angles, and we're going to talk about the unit circle briefly, so you can understand just how an angle can be substituted into a function. In the case of trig functions, the y values represent the ratio of the side lengths that are formed by the triangle that results from rotating an arm around the unit circle. This is all very confusing without a visual, so what I'd like to do is jump into GSP, where I've built out a little unit circle. Now you can't see the full thing on my screen here, but this is a circle with a radius of 1. So all the way around this circle, the distance between the circle and the origin is 1. Now, any point on this circle as I rotate my arm around the unit circle, we can write as x comma y using numbers, so 0.8 comma 0.6, and you can see that on my grid here. This is 0.8 on the x-axis, and this is 0.6 on the y-axis. And you can see that there's a little triangle that's formed as I rotate this point along my unit circle. You can see my angle up here is changing. It's increasing as I get closer and closer to 90 degrees. And what's interesting is if I calculate the cosine of that angle, I actually get the x-coordinate of that point. And you can see that on the x-axis I get 0.5. If I take the sine of that angle, 60 degrees, I end up getting the y-coordinate of that point on that circle. And you can see that about 0.87 here. So for trigonometric functions, what I'm doing is I'm rotating this arm around the circle. I can take that angle x and I can substitute it into either of these functions, and I'm going to get something out. And what we do is we take these angle values and output values and we plot them on a graph, and we have a trigonometric function. So let's start by taking a look at the graph of sine of x. And what I want to do is just show you what happens if I take several x values, which remember are angles in degrees, and I substitute them into the sine function. So let's take, for example, 0. If I take 0 and I place it in for x, what do I get? Well, if I jump back to my unit circle and I form an angle of 0 degrees, I'm just going to go with approximately 0 degrees, you can see that the sine is equal to 0. So what that tells me is that if I take 0, I place it in for sine, I'm going to get 0 out. Let's do another angle. So let's look at 30 degrees. If I take 30 degrees, if I rotate this terminal arm around 30 degrees, so you can see my degree measure is increasing. Let's try to get as close as we can. We'll say we'll call that 30 degrees. You can see that the value of sine is 0.5. I substitute 30 in for x, I get 0.5 out. Okay, so subbing in 30 degrees, I get 0.5. Now you can continue this down the chart. If I sub in 60, I'm going to get approximately 0.866. And you can always verify this on your unit circle. If I go up to 60 degrees here, you'll see that I get 0.867. Now that's going to round up, but that's consistent with what we see in the chart here. Now as I work my way around the unit circle, what you're going to see is I approach 1. And once I get up to 90 degrees, we see that the sine of 90 degrees is 1. And what you'll notice is there's actually a pattern. If I keep rotating that arm around the circle, we actually start decreasing back down to 0 again. Once we get to 180, we'll reach 0. And if I keep that terminal arm going all the way around the circle, I actually end up getting negative values for y until I eventually get right back up to 0 again. Now, trigonometric functions are sometimes called periodic functions because they repeat with some period. In this case, looking at sine of x, we say that sine of x has a period of 360 degrees because it takes 360 degrees to go all the way through one full cycle. If I kept going past 360 degrees, what you would see is this pattern repeating again. Now, to produce the graph of sine of x, all we really need to do is take these x and y values and plot them on our x and y axis. Now, I'm going to do that very quickly here just to keep this video brief, but all I'm doing is starting at 0 and I'm plotting a point at 0 on the y-axis as well, moving over by 30 degrees and then going up by 0.5, and so on until I've produced a nice smooth sine curve. And looking at this graph, you can see that it goes through one full cycle all the way around the unit circle in 360 degrees. And that's what we call the period. So the period of sine of x is 360. We have a maximum value of 1, and that should make sense because, remember, our radius of our unit circle was 1. It doesn't make sense for our function to go higher than 1 because we're never actually going to get outside of that unit circle. Now that's how you develop the graph of sine of x. If we take a look at cos of x and we go back to our unit circle, we can develop this graph the same way, but this time what we're going to do is look at the x-coordinate. So if we start at an angle of 0 degrees, we see that the cosine function actually has a value of 1. So if I go over to my table here, I can just fill that in as 1. And if I keep rotating that terminal arm around the unit circle, I'm going to develop a series of values that actually look very similar to the sine function. Again, repeating through one period of 360 degrees. Now it's interesting to note that cosine starts at 0, 1, whereas sine starts at 0, 0. So we say that the cosine function is phase shifted by 90 degrees compared to sine of x. So I can develop the graph of cosine in a similar way. I can just take these points and plot them on my graph. And again, I'll do that quickly for the sake of time here. But that's going to produce a similar looking graph to what I saw with the sine function. And I can take a look back at the sine function to see that the graph of cos looks very similar to sine and even shares a few key characteristics. Now, if I keep this pattern going backwards behind the x-axis, you'll see that it continues to repeat, and it'll even start to resemble the sine function a little bit more. You can picture a sine function starting here and rotating through one full period. That would look very similar to what I have here, but this function just happens to be shifted to the right by 90 degrees. So the graphs of sine and cos share similar features. They both have a period of 360 degrees. It takes 360 degrees for these to repeat through one full cycle. They both have a maximum value of 1, because remember we use that unit circle to develop each of these graphs. So just to recap, in this video what we did is we looked at an introduction to trigonometric functions, namely the sine and cosine functions, and we talked about how we can use the idea of a function, which don't remember is just like a machine where we sub in an x value, get out a y value, and we combine that understanding with an understanding of the unit circle to see how we can develop the graphs of the sine and cosine functions. Thanks for watching Effortless Math Channel.